Hey everyone, this mini lecture will cover conservative forces and the conservation of energy examples. So in this example, we're given that the 4 kilogram collar, as shown, C, has a velocity of 2 meters per second at A. So the spring constant is 400 Newton meters. The unstretched length of the spring is 0.2 meters. The velocity of the collar at B is what we're asked to find. So we plan out. So in our planning, we're going to apply the conservation of energy equation. All right, and we're going to do so between A and B. We're going to set the gravitational potential energy datum at point A or point B. So let's make way to solving this. All right, so note that the potential energy at B has two parts. So we have V sub B equals V sub B sub E plus V sub B sub G. So V sub B is going to be equal to 0.5 times 400 times 0.5 minus 0.2 squared. And then we subtract or minus 4 times 9.81 times 0.4. All right, so the kinetic energy at B is T sub B is equal to 0.5 times 4 V sub B squared. All right, so similarly, the potential and kinetic energies at A will be, so potential and kinetic energies or energies at A will be V sub A is equal to 0.5 times 400 times 0.1 minus 0.2 squared. All right, so T sub A is 0.5 times 4 times 2 squared. All right, so the energy conservation equation becomes T sub A plus V sub A equals T sub B plus V sub B. All right, and then using our values, we have 0.5 times 400 times 0.5 minus 0.2 squared minus 4 times 9.81 times 0.4. So that entire quantity is added to 0.5 times 4 VB squared. All right, so now we have 0.5 times 400 times 0.1 minus 0.2, and then that's squared, and that quantity added to 0.5 times 4 times 2 squared. All right, for us, this yields V sub B is equal to 1.96 meters per second. In our next example, we're given that the 800 kilogram roller coaster car is released from rest at point A. We're asked to find the minimum height h of point A so that the car travels around the inside loop at B without leaving the track. All right, So also, we're asked to find the velocity of the car at C for this height, h of A. All right, understanding this, let's look into a plan to solve this. So note that only kinetic energy and potential energy, note that only kinetic energy and potential energy due to gravity are involved. All right, so we're going to determine the velocity at B using equations of motion. All right, and then we'll apply the conservation of energy, and we'll apply that equation to find the minimum height, h. Okay, so let's go to our solution. All right, and going to our solution, we're going to be, for us, placing the datum at A. All right, we're going to be placing the datum at A. So we have T sub A is equal to V sub A equals T sub B plus V sub B. For us, this yields 0.5 times 800 times 0 squared plus 0. All right, and then we get 0.5 times 800 times V sub B squared minus 800 times 9.81 times H minus 20. All right, we're going to find the velocity, that required velocity of the coaster at B. So the velocity of the coaster, the roller coaster at B, so it doesn't leave the track. All right, so the equation of motion is applied, and that's the equation of motion. We're going to apply it at B. So the sum of the forces, sum of F sub n equals ma sub n. All right, and this is m times v squared over rho. Okay, so we have 800 times 9.81 equals 800 times v sub b squared over what we have now is 7.5 is what we substitute in, and yields us v sub b, and solving for it gets us 8.578 meters per second. All right. All right, so now using the energy conservation equation. All right, so the minimum height, the minimum h can be determined. So using that energy equation from previous, we have 0.5 times 800 times 0 squared plus 0 equals 0.5 times 800 times 8.578 squared minus 800 times 9.81 times h minus 20. All right, and then for us, we'll get h equals 23.75 meters. All right, then we're going to find the velocity at C, right? How will we do that? By applying the energy conservation. All right, energy conservation. So we'll say T sub A plus V sub A equals T sub C plus V sub C. All right, so this yields for us 0.5 times 800 times 0 squared plus 0 equals 0.5 times 800 times V sub C squared minus 800 times 9.81 times 23.75. All right, and that yielding V sub C is equal to 21.6 meters per second.